Right now, you're moving over 1,000 miles an hour sideways. So why don't you feel a thing? That's not an exaggeration. If you're near the equator, the ground beneath your feet is spinning at about 1,037 miles per hour. That's faster than the speed of sound. Faster than a bullet from a handgun. So why isn't your hair permanently windswept? Why aren't we all clinging to the ground for dear life? The answer is both incredibly simple and beautifully profound. Imagine you're on a perfectly paved highway in a really nice car, cruising at exactly 70 miles per hour. If you close your eyes, what do you feel? Not much, right? You can sip your coffee, talk to a friend, maybe even forget you're moving at all. You don't feel the speed. You only feel changes in speed. It's the moment the driver hits the brakes, or floors the gas, or takes a sharp turn, that's when your coffee goes flying and you get pressed into your seat. That's acceleration. The Earth is like the smoothest car ride you've ever been on. It's been spinning at almost the exact same constant speed for billions of years. There are no sudden brakes. No sharp turns. We and everything around us, the air, the buildings, the oceans, are all moving along at the same steady pace. We're all passengers in the same cosmic vehicle. Okay, so that explains why we don't feel like we're in a blender. But it leads to another question. If we're moving so fast, why can I jump straight up and land in the exact same spot? Shouldn't the Earth just move out from under me? This is where a little concept called inertia comes in. Inertia is basically physics speak for things like to keep doing what they're already doing. If something is still, it wants to stay still. If something is moving, it wants to keep moving in the same direction and at the same speed. When you jump, you're not just going up. You're still carrying all that sideways momentum from the Earth's spin. You, the air around you, and the ground below are all traveling east at 1,000 miles per hour together. It's like tossing a ball up on an airplane. The ball goes up and comes straight back down into your hand, not to the back of the plane, because the ball is already moving forward at 500 miles per hour along with you in the plane. So when you jump, you're just taking a tiny 1,000-mile-per-hour hop. There's one last piece to this puzzle. If the Earth is spinning so fast, why don't we get flung off into space like water off a spinning tennis ball? The answer is our planet's built-in safety feature, gravity. The spin of the Earth does create a tiny outward force, a centrifugal force, that's trying to throw you off. But here's the thing, it's incredibly weak. Gravity is pulling you down with a force that about 300 times stronger than the spin is trying to throw you out. It's not even a fair fight. Gravity is holding you in a cosmic bear hug, and it has no intention of letting go. In fact, the only effect this little battle has is that you technically weigh a tiny bit less at the equator than you do at the poles, where the spinning force is zero. So, if you want to lose a little weight without dieting, just take a vacation to the tropics. Don't expect to notice a difference, though. So the next time you're standing still, watching a sunset, just remember, you're not still at all. You're on a giant, spinning spaceship, perfectly in sync with everything around you, on a silent, high-speed journey through the cosmos. This is Nexus Point, where science meets imagination. Subscribe for more weird questions that make you think and smile.